Black math! Give me some math and I'll give you some flack. Black math!
But we're talking about the ratios of similar figures of their area. We realize that it's not the same as like the perimeter. Like if it's one triangle is 3 times as big as the other triangle, you don't just multiply by 3. So the ratio of the areas is going to be whatever the scale factor of the similar triangles is squared. So if this is 2 to 5, the ratio of the area is going to be
2 squared.
4 to 25. Come on, come on.
I said 2 squared.
Did you?
Yeah.
Okay.
I said 2 squared.
Well, 2 squared, yeah, but that's only half of the ratio.
Yeah, whatever.
So it's not just 2 squared. You can't just multiply by 4 because you have another. It's not like a 4 to 1 ratio. It's not a 2 to 1 ratio. It's 2 to 5, which is weird. So to find the area of this triangle, well, that is going to be a little weird. So area of the little triangle over what was this? 500?
Yeah.
Has to be proportionate to this 425.
Okay.
You see what I did?
So
there's not a nice little scale factor. The scale factor is like 2.5. Or 5 halves. Okay, the scale factor is a little weird. You can multiply, but so let's just fish method that, or you can figure out how many times 25 goes into 500 and then multiply 4 times that. But what is it?
4 times 15.
You got it?
Give me 2 seconds.
Because remember this area, if you couldn't figure out 1/2 base times height, which is what Tori already did.
27. 20 times 4 is 80.
That was
So 80
500.
over 500.
80, that's right, good.
I said it first.
80 square centimeters. So,
I swear I said that at some point. I said a lot of numbers.
all right, well, there's multiple ways to do this. Like if this is a 2 to 5 ratio, then you could figure out the base here. So let's see, 2 to 5, so this base
Would be
is
10.
going to be B is to 25 as 2 is to 5. Yep, so that would be 10. So then you can figure out the height. Same thing. H is to 40
That's what, 8,
as 2 is to 5.
16.
So that would be 16. And then you can multiply 5 times 16, which is 80. Or 1/2 base times height. Okay, so see how there's multiple ways to do it? But if you already have the area here and you have the ratio, just pop it into that fish method and you'll be fine. Okay? All right, so that's basically it for 87. Let's do 88. Again, I'm so sorry. If you want further explanation that you can't find in the book, I think most of this is pretty self-explanatory, but on the one day that most of you are gone, I forgot to record the first half of it.
I have a question. How many people actually watch the videos?
I don't know. I don't want to think about it because I'll get sad.
Yeah, I'm gonna look.
How many views we got?
It's like just the last one.
All right, I need to take attendance first of all.
It got 1 view.
Nice.
The last one?
Yeah. No, that was for the last one. Saxon geometry lessons 85 and 86. 1 view.
I thought I told you I didn't want to know.
Sorry.
What's the video with the most views?
8. Lesson 81 and 82. Looks like your Algebra 1 ones get more views though. And pre-algebra.
Wow. Okay. All right, so 88. Let's do 88. And then I'm going to have more Pop-Tarts. Or my last one. So we're going to graph and solve linear equations. We did this in Algebra 1, but we're going to solve a system of equations by graphing.
Oh, I remember.
Okay.
this.
So let's just throw an example up there and go for it. Oh, no. We're not doing that. We are doing linear inequalities. This is fun. This is where you get to shade above the line or below the
Oh, I
line.
hated these.
What? You did?
These
Yeah.
You're going to like it.
No.
You're in a different mindset now. You're going to like
I
it.
do like geometry way better.
Well,
than
this is more
algebra.
geometry than algebra.
Algebra is
Okay?
the worst. I'm sorry.
All right. I'll try not to say the A word.
Is this
Okay.
like and? Like it could be this and this, or it could
Yeah,
be
like
this
greater
and
than
this.
or equal to, or just greater than.
Yeah.
So in the past, you remember when we did stuff like this? X is greater than 2 on a number line. You have a 2 there. And then you have to circle it because you can't touch it. And then you shade to the right. Do you remember doing that?
No.
And then if it was like X is greater than or equal to 2 on a number line, then it would be you fill it in and shade to the right. You remember doing that? No?
What? I'm pretty sure I just straight up didn't do it. Is the thing.
Yeah.
Like
Well,
half the time, stuff like this, I'd be like,
It's
I don't
one of the
want
only
to.
things that I remember. So
Yeah, it would be stuff like
that's
this.
because you're a geometry person.
It would be
And
stuff
that's
like
why-
this. I would see it, and I'm like, I'm not about that. No, that's a no for me.
Yeah. Well, so now this is just a one-dimensional inequality. So this is basically saying everything greater than 2 needs to be shaded. So see how we did that on the number line. So here's 1, here's 3, 4, 5. Everything greater than 2, that includes 2 and 1 millionth. 2 and 1 999,999, right? Like everything up to 2. So we can't shade as close as we can without touching it. So we put a little circle around there to signify, just signify that it's called, I call it an everything but. Shade everything but 2. Okay? But don't shade on the left because it's everything greater than 2. Now this is greater than or equal to, so we're not only going to shade to the right of 2, but we're going to shade 2 as well. Okay? So that was one-dimensional inequalities. Now we're going to talk about two-dimensional
I was
inequalities.
thinking of something else when you mentioned the shading, like where you would like draw an angle and you'd shade all but that like one part of the angle or something on a graph, like an XY graph.
Yep.
What is that?
So that's what we're going to do now.
Oh, shit.
Yep.
Okay.
So that's two-dimensional inequalities. These are one-dimensional inequalities. A two-dimensional inequality is just a linear equation. So here's what I'm going to do. I'm going to solve 3x plus 2y is greater than 1. Okay, so first step is to put this in slope-intercept form. What the heck does that mean? Yeah, get y by itself. So we're going to get y by itself. Everybody okay with that? So let's put this over there. So 2y is greater than negative 3x plus 1. So remember, in inequality, you can do the same thing in an equation. If you get rid of something on one side, well, if it looks like this, what is it? This side is greater than that side, so it looks like this, right? If the left side is greater than the big side. So if you take the same amount off of this side and the same amount on this side, it's going to stay the same. That's what we want. We want to keep it an inequality. Okay, so we put that over there. Now the only other thing we have to do now is get rid of that 2. How do we get rid of the 2? Divide by 2. So y is greater than, everything needs to be divided by 2. Okay, everything needs to be divided by 2. So negative 3 halves x plus 1 half. See how I just cut both of those terms in half. Everybody okay with that? So now this gives us slope and it gives us intercept. So on an XY graph, how do you graph negative 3 halves x plus 1 half? How do you graph that? Well, you have the two things you need. You have slope and intercept. Where do you start?
You find the slope and then you start doing the intercept. sorry, you get the intercept and you start.
Yep.
Oh, isn't there a formula you use though?
Yep. So for slope is just rise over run. Okay. The intercept is right there, right?
Yeah.
If it's 1/2, it's just right in between 1 and 2. Okay. So then how do you do a slope of -3 over 2?
It's what, negative.
So from here,
So it'd be
you just,
like in between 1 and 2. In
okay,
between
if you were,
-1 and
if that was the intercept, then yes. But no, this is where you start, and then you forget about the intercept, and then you go in this direction.
Yeah, and the negative side.
So, but this is rise, you rise -3. So that means go down 3,
Yeah.
3, and then you go right, you run +2. So that's 2 to the right. So it's about right there.
Will this be on the test?
Yes. No, you got it. Listen.
No,
This
no. I'm just trying to decide what problems I can skip on the test.
This is what we did so far. We got y by itself. The only reason we did that, oh, I made that, it's supposed to be just greater than. The only reason we did that is because this, when you get y by itself, the other side tells you the secrets of the equation. Tells you where to start and in what direction to go. You start at 1/2 on the y-axis and you go down 3, right 2. If you forget, just say this out loud in your room. -3 over 2. -3 over 2. Okay? So connect the dots. And this is what that line would look like if it was an equation.
And then you
But
shade, right?
it's a dotted line, so you do have.
Okay, hold on. We haven't taught that yet. So this is what the line would look like if it was an equation. So you would solve this just like you would solve an equation. The only weird thing, remember when you divide by a negative, you have to flip the sign. Do you remember that dumb rule? So show your work because you might get that wrong if you don't do that. So, but if this was equals, it would be this line. But it's not equals. It's greater than that line. And what does y measure? It measures up and down. So this translated exactly, watch this. Watch my marker. Y, so you're going to shade above, because this is greater than, you're going to shade above this line. This line is this line. If you shade above the line, it's going to be up here. But you don't want to include the line. So we can't just draw a big circle like we did here. We did like an everything but, because we didn't want to include 2. We wanted to shade above the line, but not include the line. So the solution to that 2-dimensionally, instead of a circle, is a dotted line. Okay? So it's kind of like when I was a kid, I think I shared this with you, being vulnerable. When I was a kid, I really thought, I lived in Iowa, and I really thought when I crossed the border from Iowa to Nebraska, I would see a line. Like, where's that big dotted line that we see on the map? Well, there's no dotted line. And so like I'm a little kid flying in an airplane, and I say, oh, I see Iowa. I see the line. And that was just some dude's cornfield because we were in Iowa. Okay. But I really thought there's a line there, but it's not. But that border separates it, but it's not an actual line. So this is kind of like you want to shade above it, but this is just a reference. This is just a reference for us. So we're just going to shade above that line. Okay. Now, usually you can tell what's above and what's below it. If you're crazy backwards, eclectic, or dysgraph, I don't know how to say dysgraphic backwards. Dysgraphic. So if you're anything like that, then this might be a little weird for you, but you can usually tell what's above ground and what's below ground. If this was less than, you would shave underneath that line. But if it's greater than, you shave above the line. Okay? All right, let's do another example. Now, if this was greater than or equal to, you would want to include the line. Just like you would shade that 2 in. To include the line, you just leave it solid. what we should have done is thought ahead, and instead of connecting those dots with a dotted line or a solid line, just do it dotted. You can always do it dotted first and then fill it in if this is greater than or equal to, but it's not, it's just greater than. So it has to be above it, but not including the line. Okay, let's try another one. Let's try, let's graph this. I just want to graph y is less than 1/2 x plus 3. So this is nice. Why is this nice? Why is this?
Why it's by itself?
Yeah, it's already by itself, so it tells you the secrets.
So
How do you graph this?
you draw your little graphy line, right? And it's rise right here. So it's like the first point is up 3 there, right?
Yep, up 3. Boom.
Yeah, and then the next one is half, but it's greater.
Yeah, so don't think of it as half. Think of it as 2 numbers.
Well,
'Cause
1
remember-
over 2, 1 over 2.
This is rise.
Over run. So
This
it's
is-
1 over 2.
So up 1
and
over 2.
Yeah.
Up 1 over 2. Up 1 over 2, and so on. So this is, if I go backwards, it's down 1, left 2, down 1, left 2.
Yeah.
So what do I do with that line?
It's, what is that? Oh, so you shave below it.
Yep, so you're going to shade below it, and then what do I do with the line though?
You dot,
You dot it.
Yeah.
That's right. So if you're just doing points like that, you could technically just leave the dots. You don't even have to do a dotted line if you're just doing the points. Just don't connect the dots. Okay? Put a few more dots in there so we see, but you could just do that. And since it's less than, this means we're going to shade below.
yeah.
So that looks like this. That's pretty cool. So you know how to graph a line. Just get y by itself. Start here. Go in that direction.
That's
Up that much. Right that much. Okay. And then shade either below or on top of it. Okay. Next one.
Oh, doing another?
Of course.
I think there's like 2 examples.
Well, the good news is this is the last example. Unless you want another one.
Do you have any chance to wander around my Flack and how points up?
Let's graph this equation. Let's graph y is greater than or equal to 2x minus 1. Okay, how do we do this?
Oh, it's 2x.
Allie, since we have less people in here, can I call on you? Are you going to be embarrassed if I call on you? Depends on if I get it. Okay, so this is already in slope intercept form. So where do we start? I'm going to use this same graph. Where do we start? Where do we start in that one?
You can do the intercept point.
Yep, so where is that?
-1.
-1. So right here. Good?
And then you just go up 2 and over 1.
Yes, because there's no fraction here, so turn it into a fraction by putting it over 1. So whenever it's just a whole number or a counting or an integer there, then it's always over 1. So you're going to go up or down, whatever that is, and then over 1. So up 1 over 1 looks like this. Up 1 over 1 looks like this. Or up 2 over 1, sorry, looks like that. So it's looking like this. All right, now what do we do with that line?
Would it be a actual line?
Yep,
since it's
solid
equal to-
line because it's greater than or equal to. So that's easy to remember because if there's a line under it, there needs to be a line on the graph, okay? All right, now where do we shade?
Greater than 1.
So point with your finger. Do we go there, shade there, or there? Yes, above. So see how sometimes it's hard to see what's above, but that's a really big hill. So what's above the ground is this side, not this side. Okay, so this guy would look like this. Okay, now what gets really cool is when you have a system of linear equations and linear inequalities. And so what do these two have in common? Well, just this section here. So then if you did the system of linear inequalities, you would just shade this right here, that angle that Tori was talking about. You're shading there. So it only breaks this up into 4 different sections. You just have to figure out which section you have to shade. Okay?
Yeah.
That's it.
Black math, give me some math and I'll give you some flack. Black math.